So we were discussing about what you call freezing of fruits and vegetables. In this, where fruits or vegetables are rich sources of water. So with that, because of that reason, it is going to be damaged or spoiled. Or when you freeze the substance, freeze the water, then it is going to be stored for a longer periods of time. So we have seen aspects like your the basic aspects. So microbes and enzyme activity will be reduced because of freezing. And then we have seen what is the difference between the cold storage and the freezing. So basically cold storage is nothing but where water does not freeze. That is above minus 2.2 degrees Celsius. From 16 degrees Celsius to minus 2.2 is the cold storage, and minus 4.4 and above is the freezing temperature. And you have seen understood about the freezing of pure water and the presence of dissolved substances which causes delayed freezing, right? And then the differences between a cold storage and a freezing. So where the cold storage is the one which helps to store for a few days to weeks, the freezing is the one which helps to preserve the food for months or years. And the difference in the temperature and the difference in the rate at which the microbes cause spoilage. And then you have characteristics of food, so where the basic property is used for the preservation of the food. The lower the presence of your soluble solids like your organic acids or proteins or salt, sugar, minerals, these are the ones which will lower the freezing point, and it will take more time for the freezing point. See, for example, you have pure water which freezes earlier than the salt water or the sugar water, that is syrup, right? And then we have gone through the different methods of freezing. We have five different methods: so short, quick, freeze drying, dehydro-freezing, and cryogenic freezing, right? So we have discussed about short freezing, so where it is a temperature of minus 15 to minus 29 degrees. It takes a very long time for freezing. The time required is also very long, so 3 to 72 hours. The ice crystals, so in the case of your short freezing where it takes more time for freezing, the ice crystals in the intracellular spaces will be larger, which causes damage to the tissue, right? Just remember the time and duration and the crystal size, and then what do you call the thawing. So the substances which will cause the thawing. So there is a difference in short freezing and quick freezing. So when it is being thawed, the better quality you will observe in the quick freezing. And in the case of your quick freezing, if you see this difference in the temperature, so there the temperature is minus 15 to minus 29 degrees Celsius. So here the temperature is 0 to 4 degree Celsius, right? Then we have seen the different sizes. Smaller size, there in the small quick freezing or slow freezing. Slow freezing, it is a larger size, and the disturbance of the cell structure is minimal in the case of your quick freezing. And we have seen quick freezing by using uh, like or brine or sugar syrup, so where you use a medium which is edible, wherein which you are going to dip your fruits or berries, so for storing the substance, right? But whereas in the case of your indirect freezing, so the direct freezing is where you use brine or a sugar syrup at a temperature of minus 18. In the case of indirect immersion, uh, so you don't use edible substance, you use certain preservatives, certain what do you call so ammonia or chlorofluorocarbons or freon can be used as a refrigerant for freezing of the substance. And we also seen there are different uh, advantages and disadvantages of direct immersion. So the rate of heat transfer is more in the case of your direct immersion, so than the indirect immersion. It takes very less time, and it adds flavor and color, preserves the color and flavor of the foodstuff in the case of your direct immersion, right? And certain disadvantages, viscosity will be a problem in the case of your quick freezing, right? And we have stopped somewhere here in the quick freezing, so where we were using plates. So the refrigerant we heat the or cool the plates, so thereby it transfers the heat to the foodstuff, right? We are here somewhere, right? So in the case of your quick freezing by air blast freezing, so here, so instead of the plates, it uses air, so which is blasted. So it uses air which is blasted, um, and you can see in the slide. So wherein, see in this case, so these are the substances, that is your food substances, so which are placed in the stacks in the form of stacks, and the cool air so is blown from, this is a cooler, so from this cooler cool air will be blown. So this is, from this cool air will be blown onto this food packets or the substances that need to be frozen. So that is blown. So when it is blowing cold air through blasting, so your substances get frozen, right? Are you able to follow, Narama, Lera?
Sir. No, sir. Yes, sir.
Okay, so this is air blast freezing. So in this video you can see air blast freezing of, this is used. So these are the food packets. So they are here. Here it's shown as prawns. So the prawns are being air blast frozen. So these are the trays. So this is an air blast freezer. These are placed into the air blast freezer and they get frozen, right? So this is how a foodstuff is being frozen by using this air blast freezing. So under quick freezing, we have three different methods, that is direct immersion, indirect immersion, and then quick freezing, right? So under this, you have two methods under indirect freezing or your quick freezing. So two methods can be followed, that is by rapid freezing technique ways, that is fluidized bed freezing and plate freezing. So you have two methods, that is fluidized bed freezing and you have plate freezing, right? These are the two methods by which a food can be quickly frozen. So in the case of fluidized bed freezing, it forms like a bed over which your product, it in roll over, underneath it will be blowing with cold air. So this will be moving on a bed, on a conveyor belt, which is having perforations, isn't it? Can you see the slide? Yeah, those who have good atmosphere, you can switch on your microphone. So unless there is a disturbance in the background, you can switch on your microphone so that you can respond, right? So in this here, there is a conveyor belt over which your product runs. The cool air will be blowing from underneath. The cool air will be blowing from the underneath. See, from here cold air will be blown. Your products like strawberries, your blueberries or grapes or anything, whatever needs to be frozen, those can be allowed to pass through this conveyor belt or fluidized bed, and then cold air will be forced onto this produce, and then it comes out of the conveyor belt or a fluidized bed, right? So this is how IQF products. So IQF, individually quick frozen vegetables are frozen by using this air blast freezing. So this is one technique where it is productized frozen individually. See here you can see clearly how the cool air is blowing, how the cool air is blowing and the product is getting frozen. See here, the cool air is being blown and the product is raised. So when it is blown, it will be lifted slightly from the conveyor belt and it will be frozen. So you can see different stages. So this is the loading zone where the produce is loaded, and slowly by the time it reaches the finishing, it will be completely become frozen. So that is fluidized bed freezing or air blast freezing. So where there is like forced percolation of air, forced air onto the foodstuff. Here this is a plate freezing. This is like indirect method of freezing, indirect cooling or indirect immersion. See here you can see on a plate freezing, the foodstuff is placed like this. So here this is the foodstuff. The foodstuff is not in direct contact with the refrigerant like your ammonia or brine. So these are the plates. So these are the plates which contains your refrigerant. So these plates, so what they will do? So they will freeze your foodstuff that is placed in between the metals. So the product is placed in between this metallic plates, and then they're placed and then they are pressed in between the plates, freezing plates. So then the foodstuff is going to be frozen by using this rapid freezing techniques. Is it clear? So the plate freezing is done by this, where the foodstuff is placed in between two metallic plates, and then it is allowed to freeze by indirect method of freezing. Right? The foodstuffs like your squash, so they will be purees. It can be frozen by using this technique. See here, you can see the clearly how the produce is placed between the plates. Right? So what are the advantages of fluidized bed freezing and plate freezing? So in the case of your fluidized bed freezing, so it gives sufficient heat and rapid heat transfer, and the extent of dehydration is less, and defrosting equipment is not required. So because so it will be heating or freezing the substance to a very short extent. So there is no requirement. What is defrosting? Defrosting means, so sometimes in the refrigerators, in the freezers, there will be excess accumulation of ice. So that excess ice has to be defrosted by using a defrosting equipment or defrosting button. Have you observed any defrosting button? Nowadays, you are not getting. All our olden days refrigerators are you need defrosting buttons. So this nowadays we don't have this problem of defrosting, but usually when you're using this kind of freezing techniques, so there will be excess formation of freezing. See, I'll show you how a quick frozen strawberries are being seen and being carried out. In the case of strawberries, they are freshly harvested and they are transported. They are sent to the freezing centers. Can you see the video?
Video is
Huh?
no sir. No sir.
Huh? Video కనిపిస్తుందమ్మా?
No sir.
No.
No sir.
Now can you see? కనిపిస్తుందా?
Yes sir.
Yes. Okay.
Yes sir.
So here, so for harvesting the strawberries, and they are being transported. These are called as IQFs, individually quick frozen. So that means each strawberry is frozen. So the pre-treatment involves washing, and they are subjected to freezing. See, now these are quickly frozen. See, after washing, they have been sent to a fluidized bed freezer. This is after freezing. So these are frozen ones. These are completely frozen ones. So those are called as IQFs. So individually quick frozen strawberries or individually quick frozen fruits. Can you see the slide now?
Sir.
Slide చూస్తున్నారమ్మా?
Yes sir.
Okay. So back to the presentation. Here we have seen the fluidized bed freezing. So that is what you have seen in the case of your IQFs. So they will be slightly raised when they are passing through the bed, and then they will be frozen. And there is another method of freezing, that is your plate freezing. So where it is placed between the plates, and the plates are the ones which are uh, which become cooler, and then this coolness will be transferred onto the food stuff, right? So when you compare, so we have finished right now quick method of freezing and slow method of freezing. So under slow method, there is only one method, that is it takes longer time. What is the time duration? 3 to 72 hours. In the case of quick freezing, what is the duration?
Minutes.
Hmm?
30 minutes sir.
Right. So
Yes.
it takes shorter time in the case of quick freezing. So you can see the difference between quick freezing and slow freezing. So in the case of your quick freezing, the ice crystals are smaller or larger. So this is the produce which is frozen by quick freezing. You can see smaller ice crystals. But whereas in the case of your slow freezing, the ice crystals are larger. Can you see the ice crystals? So they are piercing through the cells, causing damage. So when they cause damage to the cells, so there will be oozing of metacryolitic liquid. So that is nothing but your presence of protoplasmic liquid, which contains salts and organic acids or proteins. So they start oozing out, which are not frozen. So certain foodstuff will not be frozen even though there is surrounding substances that are being frozen. Understood? సో కొన్ని పదార్థాలు ఘనపరచకుండా అలాగే ఉంటాయి, like your proteins, sugars, but the liquid component like your water and pure water and other substances get frozen, but there will be substances like your proteins and other substances like your organic acids or salts or sugars, so they remain in the liquid phase. So when these larger ice crystals, they pierce the cell walls, so then they cause damage to the cells, and the oozing of liquid, so that is called as metacryolytic liquid starts oozing from these cells. So that is the great disadvantage in the case of your slow freezing. Whereas in the case of quick freezing, you don't see such problem because the ice crystals which are formed are very smaller. Clear? And go to the next slide. Right? This is the same advantages is explained. And then cryogenic freezing. So we have completed two methods, slow freezing and quick freezing. So there quickly go through this third and fourth and fifth. So cryogenic freezing is nothing but freezing using either liquid carbon dioxide or liquid nitrogen. So this will be directly in contact with the food. So initially the food will be pre-cooled and then they will be dipped either in liquid carbon dioxide or in liquid nitrogen. So the temperature will be minus 60 degrees Celsius. So instantly the food becomes frozen. So because of this liquid nitrogen and liquid carbon dioxide. The problem with this cryogenic freezing is initial high investment and operation costs and cryogen residue in the food. So presence of liquid nitrogen or liquid carbon dioxide residues in the food is the main problem in this. So this provides the latent heat of evaporation or sublimation of the cryogen. So this cryogen will be in close contact with the food, which removes the heat. That is how it removes the heat from the food. Say for example, the removal of heat from a foodstuff is the key for freezing. If it is able to take out the heat from for example, a strawberry, so it takes out the heat quickly from the foodstuff, so that helps in quick freezing. That is provides latent heat of vaporization, so that this CO2, NO2, N2, so this has the property of quickly removing the heat from the food. So that will make it as a good substance for useful as your cryogenic freezing agent. So this is how a foodstuff. These are the prawns, and these are berries, blueberries or blackberries, and this is your strawberries. So which are being frozen by using your liquid nitrogen. So cryogenic freezing using liquid carbon dioxide. So when a gas is released into the atmosphere at minus 70 degrees Celsius, so half the gas becomes dry ice and snow, and the other half stays in the form of a vapor. So you will see a dual stage of carbon dioxide because half of it will be in the form of snow, half of the carbon dioxide will be in the form of vapor. So this property will be used in pre-freezing treatments before it is exposed to nitrogen spray. So before exposing this foodstuff to the liquid nitrogen, so they will initially cool down the produce by exposing them to the carbon dioxide, liquid carbon dioxide. This helps to initially reduce the temperature. So that is cryogenic freezing. And then you have cryogenic freezing using liquid nitrogen. So liquid nitrogen is usually colorless and odorless. So what is the temperature, boiling temperature of liquid nitrogen? It is minus 196 degrees Celsius. So this is quickly will freeze your food. So at minus 196 degrees Celsius. The food has to be initially pre-cooled with the carbon dioxide, and then it will be exposed to the liquid nitrogen. So then the food stuff will be frozen instantly. So either it will be done in the form of sprays or in the form of dipping directly into the food stuff. So you can freeze the produce. So like your seafood, berries, all these things can be frozen by using cryogenic freezing. The next method is dehydro dehydro-freezing. So dehydro-freezing is nothing but freezing by employing dehydration first followed by freezing. So if you dehydrate initially by taking out 50% of the moisture. So first you need to take out 50% of the moisture prior to freezing, and then the produce is frozen. So that is the name itself indicates. First you dehydrate. So how much, to what extent? To an extent of 50%. Then you freeze the produce. So then you will get a more stable and better quality produce. This is dehydro freezing. And the next method is your freeze drying. So freeze drying or sublimation or lyophilization. So these are the other names for this freeze drying method. So wherein, so initially you will freeze the produce and then you dry the produce. So initially you're freezing to an extent of minus 18 degrees Celsius. So you freeze it to minus 18 degrees Celsius, and then you will dry it at what temperature? At 30 degrees Celsius. So for at what pressure? This is most important. At a pressure of 0.1 mmHg. So when you heat it at a temperature of this 30 and 20 degrees Celsius under a high vacuum of 0.1 mmHg, mercury, so what will happen? There is a process called sublimation. So what is sublimation?
Solid gas.
Yeah, yeah, usually the food, the component of the state transfers from solid to liquid and liquid to gas, isn't it? This is the usual phenomenon. But in the case of sublimation, when a food is being frozen, so what will happen? It will convert into ice or solid ice. So due to the process of sublimation, the ice, instead of getting into the liquid phase, it will directly go into the Monica, directly go into the
Vapor phase, sir.
right. It will directly go into the vapor phase. So because of a reduced pressure, so it is under high vacuum, the pressure is reduced and the temperature of evaporation will be reduced. That means at 30 degrees Celsius or 20 degrees Celsius itself, water starts evaporating, isn't it? So at a very, so usually water, when it starts evaporating at a temperature of, at a temperature of, when it starts evaporating,
100 degrees centigrade.
yeah, 100 degrees Celsius. When the pressure is reduced, the temperature of evaporation decreases or increases. Ashwini, the Ashwini. Lavanya, Jittu. So when the vacuum is created, that is pressure is reduced, temperature of evaporation whether it decreases or increases.
Increases. Increases, sir.
Increases. It is clear now, ma. Boyle's law. It decreases. Pressure is directly proportional to temperature. When P is Malika, huh?
Evaporation and then temperature.
Malika. So when it is reduced, pressure is reduced, the temperature of evaporation will be increased or decreased?
Decreased.
Decreased. So at lower temperature itself, the water starts, that solid ice starts evaporating. So that is the basic aspect here. That's why you will get very good quality produce as a result of there is no damage that is caused because of this change of evaporation. So that is why the product which is prepared from freeze drying will be of a better quality. So here, in the case of freeze drying, it will be frozen. The product will be frozen at minus 18 degrees Celsius, right? And then ice will be formed, right? So this ice has to be removed without allowing it to convert into liquid. So by sublimation. So that will be conducted by exposing it to high vacuum or low pressure, that is zero point 0.1 mmHg. So at this low pressure, the temperature required is 30 degrees or 20 degrees. Your solid ice will be converted into vapor. So which is called as sublimation. I hope you understood, right? So these are the different methods of freezing, right? And changes during freezing. So you will see certain changes during freezing, which include your rapid, uh, quick physical changes and chemical changes. So since this foodstuff is frozen either by using quick freezing or sharp freezing, there will be formation of ice in the case of quick freezing rapidly, and it gets frozen rapidly, and then the case of your sharp freezing less rapidly, right? And even the physical changes like your changes in the volume and formation of ice crystals is different in quick freezing and sharp freezing. So during the formation of a frozen substance of the food, so these ice crystals they starts to form and then they cause damage to the tissues. So when there is formation of larger ice crystals, this will cause damage to the cells, and then you will see syneresis of hydrophilic colloids. So syneresis means weeping. So means the substances which will like water will start oozing out. So this is a damage so that is caused during freezing. So the freezing will help in the preservation of the food by um, reducing the rate at which these microbes grow. So either they will become the microbes either become susceptible or moderately resistant or insensitive to the applied low temperature. So these vegetative cells, yeast, mold, and many gram-negative bacteria, they are very susceptible to these freezing conditions. So they get killed as a result of freezing. But some of the gram-positive bacteria, like your Staphylococcus enterococci, they are moderately resistant. And the spores, bacilli, and clostridia, they will not get killed because of freezing. So that's why freezing is not the solution for a permanent storage of food because it slows down. So even these spores, bacilli and clostridia will continue to thrive, right? So here we can see certain aspects in a frozen product. So what are the different changes when you observe when a produce is being frozen? So one, we have seen slowdown of chemical and enzymatic reactions. The chemical enzymatic reaction, they continue to occur at a slow pace in the case of your frozen produce. And because of the differential ability of the solutions. So in a medium, in a fruit or a vegetable or in a juice, all the foodstuffs won't be freezing at the same time, right? So they will be having different freezing points. So that's the reason why. So some of the aspects, some of the substances, they get frozen early than the others, and some other substances will not be frozen at all. So during that freezing process, when the frozen product is stored, so there may be oozing of metacryotic liquid. So this is metacryotic liquid. So this starts oozing because of the difference in the freezing points when there is a storage, and then increase in the size of the ice crystals. So when you store the foodstuff in a freezer, uh, when you initially follow the process of quick freezing, there might have been formation of smaller ice crystals. But the thing is, over a period of time, due to the fluctuations in the temperatures, so it cannot maintain as a regular same temperature. It may be fluctuating. What will happen? The small ice crystals, so they will coalesce. So they will come together and they form larger ice crystals. So which will cause the damage to the food, right? And the desiccation of the food. So these are the changes. I'm talking about the various changes which occur during freezing of the produce. During freezing, what will happen? The surface of the fruit, so when it is like sublimation, you know the sublimation, just now I have explained, wherein there is a ice formation. So when this ice starts evaporating, so it will not only lead to freeze burn, but also it will lead to desiccation of the food. It will cause brown spots or losing of moisture from the food as a result of sublimation. By the freeze burn formation of freeze burns or black spots you may get in the storage. And then one more change is decrease in the number of viable microorganisms. So these are the various changes. Slow but continuous decrease in the number of viable microbes in a frozen produce. Right? If you classify these changes during storage of frozen produce, you can classify them into physical changes and chemical changes. So losses usually are higher in the case of a storage period than in the initial freezing or thawing. So you will see more changes in the normal storage period of this frozen produce. So this classification can be done as physical changes and chemical changes. Physical changes and chemical changes. So under physical changes, you have recrystallization. Recrystallization, nothing but small crystals will merge to form a bigger crystal, causing damage. Right? Sublimation. Sublimation is nothing but the ice that is being formed which starts evaporating without entering into the liquid phase. So that also even causes damage. And denaturation. So denaturation is nothing but losing the structure. Right? So let's see one by one. So here the first one being the recrystallization. So recrystallization forming smaller ice crystals. So they will form bigger ice crystals. So this is due to the temperature fluctuations. So temperature fluctuations during storage will cause recrystallization. So that means smaller ice crystals form larger ice crystals. And the case of sublimation, so I already explained you about this sublimation. So from the surface of a fruit, when it is starts so subliming, like for example, we have a fruit. We have fruit. So on the surface of the fruit, so if there is a formation of ice. So this ice so starts evaporating. It starts evaporating. So this ice component directly converts into vapor. So as a result of conversion of this solid ice into vapor, this leaves a scar. This leaves a blemish. This leaves a blemish. So which will lead to the damage to the tissue, right? So that is about the sublimation. And you have denaturation. So the protein alterations that is observed. So that is so when there is an increase in the ionic concentration in the freezing. So through the reduction of the water content, the protein will form bonds with each other instead of water and insoluble complexes. So this is nothing but differential ability of freezing. So water is the component which will be frozen. So the protein has to form bond with the water molecules. It has to be uniformly distributed. But what happens in the case of denaturation? The protein will form a bond with another protein. So that will be causing denaturation of protein will lose their structure. So two different proteins forming bonds with each other. So instead of being free in the water, they start moving as a mixture or a bond with another protein. So that means two different proteins they will bind together. So because of this differential freezing, right? And then thawing. So this is once the food is being frozen, it has to be brought to a normal state. So that moisture that as size has to be like removed by using thawing technique. So certain damages that you will see in the case of thawing. So if you place it in a thawing by using microwave or something, the ice has to be slowly removed. So that the produce will become fresh. The meeting is going to be end soon, and then there is 4 5 slides. Again, we will rejoin. Okay, so I'll continue with the changes in storage. I'll finish it off in 10 minutes. Okay.